Bismillahirrahmanirrahim. In today's lecture, we are solving problem 3.24 from Applied Thermodynamics by McConkey. So, problem is a vertical cylinder of cross-sectional area A. First, I write given data. So, in given data, cross-sectional area is equal to 6,450 square millimeter. I convert this to square meter, so this will be equal to 6,450. When I convert this to divide by 10 power 6, so 10 power minus 6 square meter is open to the atmosphere at one end and connected to a large storage vessel at the other end by means of a pipeline and wall. A frictionless piston of weight 100 Newton. Weight of the piston is equal to 100 Newton. A spated cylinder and initial volume is negligible. Initially, this is cylinder, this is piston. Initially, this will be closed with this. This is piston. Initially, there is no volume. It means that P initial pressure is 0. No volume, so pressure is 0. Initial mass is 0. Initial mass is 0. Similarly, initial volume is 0. Similarly, initial internal energy is 0. Now, the wall is then opened and the air is slowly admitted from the large storage vessel into the cylinder until the piston has moved very slowly a distance of 0.6 meter. A distance of 0.6 meter. So D is equal to 0.6 meter. Now we can find the initial volume is 0 and we can find the final volume because now the piston moved by 0.6 meter and the piston cross sectional area is 6,450 multiplied by 10 power minus 6 square meter. It means that final volume is 0.6 this length multiplied by this area. So 0.6 meter 0.6 meter multiplied by 6,450 multiplied by 10 power minus 6 square meter. So this implies that final volume will be equal to 0.00387 cubic meter. 0.00387 cubic meter. Now addition of 0. When the wall is shut, if the temperature of the air in the cylinder is 30, this is T double dash. T double dash is 30 degrees centigrade, which is equal to 8273 degrees centigrade to convert this into Kelvin, 303 Kelvin. And the temperature of the air in the large storage vessel, this is I name this T. This is not T dash and not T. T dash T is equal to 90 degrees centigrade and 90 plus 273 is equal to 363 Kelvin. This is the temperature of large storage tank which supply the air to the piston cylinder. Now calculate the pressure of the air in the cylinder during the process required. Number first, P double dash is required. Number 2, work done on the air during the process. Work done on the air. Number 3, work done on the piston. Work done on the piston. Number 4, the heat supplied to the air in the cylinder during the process. Find Q. And take atmospheric pressure is 1.013 bar. 1.013 bar. This is the given data and required. Now we start solution number 1. So first we find pressure in the cylinder. For this we find we use equation of work done. We know that work done is equal to P V2 minus V1. We can find this from the formula W is equal to integral of 1 to 2 PdV. So pressure is constant, and take integration of dV. Integration of dV is V, lower limit is 1 and upper limit is 2. So apply upper limit and lower limit, so this will be equal to P2 minus P1. And there is the effect of atmospheric pressure, so I write this as subtract atmospheric pressure from final pressure, P double dash minus P into V. I can write V2 as V double dash minus V1 is a V dash. Work done is equal to force multiplied by displacement of the piston into P double dash minus P into V double dash minus V dash. Now put values in this equation to find P double dash. So weight of the piston is a Newton, 100 Newton is given to us. Displacement of the piston is 0.6 meter. P double dash is required, or this is P atmospheric. Atmospheric pressure is 1.013 bar. 1.013 multiplied by 10 power 5 Newton per square meter into V double dash. V double dash is 0.00387 cubic meter. 0.00387 cubic meter, and initial volume is 0 cubic meter. So 100 Newton multiplied by 0.6 meter is equal to 60 Newton meter, and divide by this value to find P double dash. 0.00387 Newton meter cube, there is no Newton, is equal to P double dash minus 1.013 multiplied by 10 power 5 Newton per meter square. Now 60 divided by 0.00387 is equal to 15503.87. 1 meter will be cancelled with 1 meter. Unit will be Newton per square meter. This minus will be plus on the other side. 1. I can write this as 101300 Newton per square meter is equal to P double dash. Now add these two values, so this will be equal to 1168.03 03.87 Newton per square meter. Convert this value into bar. So divide by 10 power 5. 116803.87 divided by 10 power 5 bar. Because 1 bar is equal to 10 power 5 Newton per square meter. So P double dash is equal to 1.168 bar. So this is the final pressure. Now solution number 2. Work done on the piston. So work done on the piston is equal to P double dash V double dash. This is negative because work done on the ear. Ear is expand. In according to McConkey, expansion work will be negative. Therefore, work done is equal to minus P double dash V double dash. So work done is equal to minus P double dash is 1.168 bar, or 1.168 multiplied by 10 power 5 Newton per square meter, and V double dash is 0.00387 cubic meter. Multiply this, and square meter will be cancelled with square meter. This will be meter. So unit will be Newton meter. Work done is equal to, multiply these values, so work done is equal to minus 452.016 Newton meter. Now work done on the piston. Work done on the piston will be positive, because when we work done on the piston, the work done will be compression, and compressed work will be positive according to McConkey. Work done on the piston is equal to, this is work done on the ear. Work done on the piston is equal to W multiplied by D. This is piston. This is piston, and weight of piston is 100 Newton. This is 100 Newton, and displacement, this is displaced by 0.6 meter. So which is equal to 100 Newton multiplied by 0.6 meter. So work done on the piston is equal to 60 Newton meter. Now we solve the last part to find the heat supply. Solution of part number 4. So for heat supplied, we will use non-steady flow equation. So first we find m double dash. So according to ideal gas equation, p dash p double dash v double dash, according to perfect gas equation, p dash p double dash v double dash is equal to m double dash or t double dash. So m double dash is equal to p double dash v double dash divided by r t double dash, which is equal to p double dash is equal to 1.168 bar or 1.168 multiplied by 10 power 5 Newton per square meter. V double dash is 0.00387 cubic meter. The value of R per year is 287 joule per kilogram per Kelvin. Joule is equal to Newton meter per kilogram per Kelvin, multiplied by T double dash is 30 degrees centigrade or 303 Kelvin. Kelvin will be cancelled with Kelvin. Newton will be cancelled with Newton. This meter square in meter is, both are in denominator. This will be cancelled with meter cube. So final unit will be kilogram, and double division, this will be in numerator. So m double dash, simplify all these. So m double dash is equal to 0.0052 kilogram. Now it is given to us in theory that the temperature of storage vessel is constant at 90 degrees centigrade. The large storage vessel is constant at 90 degrees centigrade, and we have to find the heat supplied to the air in the cylinder during the process. So as the temperature in the storage vessel is constant during the process, it is given to us as the temperature of the large storage vessel is constant during the process and specific enthalpy of mass entering the system is constant, and H is constant. Specific enthalpy of mass entering the system is constant. The system is constant. Then from non-steady flow equation, we can use non-steady flow equation in these conditions. From non-steady flow equation, Q plus W plus m double dash minus m dash into H is equal to m double dash u double dash minus u. M double dash is 0 initially, volume of the piston is negligible, so these terms are 0. So Q is required plus W. The value of W is force multiplied by already we find W for the ear, so W for the ear is 0.00452. I think this value is minus 452.016 minus 452.016, and all the values are in kilo, so I write this work in, this is Newton meter, so if I write this in kilonewton meter, so I will be divide this by 10 power minus 3 kilonewton meter, plus the value of m double dash is 0.0052 kg, 0.0052 kg, and enthalpy per year is H is equal to CPT. H is equal to this, H is equal to CPT. The value of Cp is 1.005 kilojoule per kilogram per Kelvin, and the value of T is 363 degrees centigrade, 363 Kelvin. This is the temperature of the large vessel which supply the air, is equal to m double dash u double dash. U double dash is equal to CVT double dash. So m double dash is equal to 0.005, final mass is 0.0052 kg, and the value of CV per year is 0.718 kilojoule per kg, and final temperature of the cylinder is 303 Kelvin. This is T double dash, final temperature of the cylinder. Now Q minus, if I simplify this value, this will be equal to 0. Divided by 10 power 3, 0.452.016 kilonewton meter, plus multiply these three values, so the answer will be 1.897 kilojoule, and kilogram will be cancelled with kilogram, Kelvin will be cancelled with cancel, this will be kilojoule, is equal to, multiply these three terms, so the answer will be 1.13 kilojoule. So Q is equal to, write this on other side, so this will be minus will be plus 0.452, this is not point, 0.452016 kilo Newton meter is equal to joule, and plus will be minus on the other side, minus 1.897 kilojoule plus 1.13 kilojoule. Add these two terms and subtract 1.897 from the sum of these terms. So the final answer will be minus 0.315 kilojoule. This is the final answer. And problem 3.24 is solved, and the problems of chapter 3 are completed. So for more videos and more problems, like my YouTube channel and share with all your friends. Thank you.